Really happy to be here, and thank you all. Kudos for making it to the last slide of 3 days of a full conference. It's great to see all of you here. So let me just quickly introduce myself so that you know who is up here talking to you. So my name is Sofie Van Landeghem, and I sort of have two lives in the Python community. On the one hand, I'm an open source contributor, and on GitHub I have this handle which is unpronounceable, which is called Sofie Van Landeghem. It was a bit of a joke between me and a friend back at uni, and I'm stuck with this unpronounceable handle for the rest of my career, but that's fine. So you might have seen me on repos, Python repositories such as Spacey that I helped maintain for several years, as well as more currently, I've been involved with the maintenance of Fast API and Typer, which some of you might know as well. So that's sort of one part of my career. The other part, some other days of the week, I am also a freelance NLP consultant in my one-woman company, Oxycoded. So in this capacity, I am sort of, the business analyst, the data scientist, and the machine learning programmer all at once, where I try to incorporate open source tools from the Python ecosystem, try to use open weight models and these kind of things, and try to create value for business, really. So it's in this last capacity with the sort of consultant hat on that I want to talk to you about data in machine learning projects. So let's just go through a sample, an example project where we want to create a portal with all Formula One news. So basically we have a client that is interested in collecting all of this Formula One news. Why? Because maybe not all people want to read their news or their summaries from an LLM, and they actually want to go and read the original story behind it. So we want to collect the actual stories that were published in different journals and so on. And we'll see here some of the main actors in the Formula One landscape. I'm not sure whether there's other Formula One fans out here. The whole talk will be Formula One, so I apologize if nobody else cares. I think it's pretty cool. So what we want to do on this website basically is we want to extract facts from the articles and then be able to link those facts to the original article. So in this particular case, last week, if anybody saw the race in Monaco, which is also always like a legendary circuit to run on. So last Sunday, Lando Norris won the race in Monaco. So when we know that fact, we also want to be able to provide the users with a link out to an actual news article that explains more of the details, what happened during that race, what are the consequences in the championship, and so on and so forth. As you can see, if you're not watching Formula One right now because you think it's boring, it's actually really exciting because there's basically a three-way contendership for the title. Verstappen is being challenged by both McLaren boys, Piastri and Norris, so I highly recommend watching. It's going to be an interesting year. So let's say that we have this, we have this requirement that we want to link these facts to given news articles, right? Okay, we've gone ahead and implemented some of this, and then we will have to go and watch the data. So this is always sort of a pet peeve of mine, is go and look at your data and see what is happening there. So this is an example fact that we extracted from last year. Let's say in 2024, at the end of July, there was a race in Spa. Spa is a circuit in Belgium. I am from Belgium. This is not a coincidence. So the race in Spa was won by George Russell. This fact was extracted by our system because of all of the sort of pieces of evidence that you see on the slide. We see an article where it reads about how Russell was able to hold off Hamilton for a stunning win in Belgium. We see a podium where Russell is clearly very happy, and Hamilton, and I think this is Piastri, is quite unhappy. So many sort of pieces of evidence that showcase that indeed Russell won this Formula One Grand Prix at the time. So let's just do a quick sanity check. At this point in time, our system is extracting facts, it's linking it to articles. What do you all say? Does this look like this fact is extracted correctly? Knowing that Spa is the Belgian Grand Prix? Yes? Hands up for yes? Well, not so many. Not so many are certain. Who thinks that this fact was not extracted correctly, or this is not a correct fact? No, but one person. Are you a Formula One fan? No, just sort of random guessing here. Okay, that's fair. So this fact was indeed extracted correctly from the given sources that we have here, but Russell did not win the Spa Grand Prix in Belgium. I guess some of you saw this coming, right? So you didn't dare to answer. You saw the trick question coming up. So what happened in Belgium is that Russell actually raced a brilliant race. He managed to pull off a one-stopper, so he only went to the pits once. And then he basically was able to, because of the pit strategy, was able to overtake many people and claimed victory at the end of the race. But Formula One is a heavily regulated sport, and at the end they also do like weight checks. Don't ask me about all of the details, but it turned out that at the end of the race, Russell had to be disqualified because he was underweight. He had lost a lot of weight because he was sweating so much in the car, but also his tires basically wore down significantly because he kept running on the same tires for a very long stint. So 2 hours after the race, they go and disqualify Russell and give the title to Hamilton. So then, of course, the newspapers do their thing and publish an update and say, well, actually, it was Hamilton who won it because Russell was disqualified. So that's an interesting point. If you look at just the NLP sort of side of things, if you give the natural language processing algorithm, if you give it just these two input texts, then, I think the NLP is very correct in saying that there's two different facts to be extracted here. It's not making a mistake saying that Russell actually won that Grand Prix because this is what the sentence says. And the NLP is supposed to analyze the grammar and analyze the semantics of the sentence and extract the fact correctly like it did. But in this particular case, we'll need to have some filtering in place so that we can actually deduce, well, who was in the end the correct winner of this race. And you might tell me, well, Sophie, that really isn't all that interesting, because, well, sure, okay, first we had a winner, then he was disqualified. The NLP should really be able to see the different timestamps, for instance, on the articles and sort of go with that and understand that this was an update to the result. I agree with you, but it's not always that easy. So recently, and if there's not a lot of Formula One fans in the room, then you might not know this series either, but then I would highly recommend watching this because it might get you into Formula One. So there's this Netflix series called Drive to Survive. And what it does is after each season of Formula One has ended, they basically, let's call it a documentary. They created a documentary sort of summarizing all of the races, all of what happened in last year's of Formula One season. And it's not just a documentary. There's also quite some drama going on, and they highlight the personal narratives a little bit as well. So it's entertaining to watch. So this year, they talk about last year's Formula One racing, and there was this, I think it was the third episode of the season that's called Looking Out for Number One. And the narrative here is about George Russell. So George Russell, who runs for Mercedes, and he is basically stepping into a leadership role at Mercedes. Why? Because Hamilton is leaving Mercedes. As some of you might know, he was leaving Mercedes to go to Ferrari, the Italian team, and he did just that in January 2025. So the whole episode is about how George Russell is stepping into this leadership role, how he drove a brilliant race at Spa, which is all true, and then he's on the podium, which is all true. And that's where the episode ends. They don't actually mention that he was disqualified at the end of it. So it was very confusing to me when I was watching this episode, knowing that in the end, there was this disqualification, which is not a minor detail. It's actually something that happened and which was quite important. And they don't even mention it. So this was published months after the fact. And well, like somebody on Reddit, I think, accurately puts it, it's almost like they pretended George won Spa, which is a bit weird, right? And why am I saying that? It's because this Drive to Survive sort of series is what I would call is a very authoritative resource. If you would be parsing information from there, if you would be looking at that video as a non-domain expert, you would be saying, well, that is probably what happened. Russell won it. That seems to be the case. So it's very important to sort of making sure that you watch your data closely. And I think the main takeaway from this is that what you really need is have a domain expert on board. Somebody who knows the data, who knows the domain, who knows what happened, and who won't easily be fooled by some random narrative that some producer for a Netflix series has created. So have that domain expert on board. Whenever I am working on a consulting project and there's a domain expert, I try to treasure them because they always have little nuts and pieces of information that will come in handy throughout the project. So nourish these people. Let's get back to our portal. Let's say that we have all of these articles, we have all of these facts extracted, and now we also want to provide a link out to Wikipedia. So what I mean by this is throughout the articles, when you're reading them as a user, you also want to get some background information. So who is this Hamilton guy? What is this Mercedes team about? And on the English Wikipedia, for instance, let's take English as an example, there's a lot of information about that. So we want to be able to link out to those articles. What that would look like very specifically is, for instance, here, we have the sentence that we now all know to be true. Hamilton won the Belgian Grand Prix in Spa in 2024. In case you hadn't noticed, I'm a huge Hamilton fan, so this is kind of where this is coming from. I kind of wanted to set the record straight here. I think I've done that. So in this sentence, Hamilton won the Belgian Grand Prix in Spa in 2024. Let's say there's two entities that we're interested in, Hamilton, and then the Belgian Grand Prix. So these are two entities that we can provide Wikipedia pages for. So in an ideal sort of situation, we would link Hamilton to its page on Wikipedia, Lewis Hamilton, or Sir Lewis Carl Davidson Hamilton. He was born in an awesome year as well, 1985. And then the fact that he won the Belgian Grand Prix. So there's another article about this Grand Prix. So that is kind of what we want to do. This might seem straightforward to you, but it's actually a quite difficult task because there's a lot of ambiguity involved. You need to be able to understand the context of the sentences to understand which exact article it is that we need to link to. And I'll show some examples in the rest of the presentation. So we wanted to go and build this entity linking model. And to do that, it's actually quite easy with Wikipedia. They provide all of this training data for free. And this is work that we did several years ago. So you might notice that it's still a little sort of, we were still using some sort of traditional supervised learning methods, but the learning will stand as what I want to say. So in this case, the training data that we can harvest is just for free available on Wikipedia. Because if you look at that first sentence, so Lewis Hamilton is a racing driver for Ferrari. Look at the words Ferrari. They are just sort of mentioned as Ferrari in the sentence. But if you go and look at the actual underlying, let's say, source code for the Wikipedia page, we see their links with these brackets is that they link out to an article called Scuderia Ferrari. Because obviously Ferrari is a auto manufacturer, but in this particular context, we mean Ferrari, the racing team, right? Clearly the two are related. Audio still good? Yep. Okay. So clearly the two are related, but we want to link out to the actual Ferrari racing team. So by harvesting these links, and you can just download the whole of Wikipedia and get all of these links, by harvesting these links, we can teach the model that in this particular kind of context, if we see Ferrari, then we mean the racing team. In another context, we might mean the auto manufacturer. And this is how we train a model to look at the context and then find us the correct page to ambiguate to. And then that will be our link out on our portal. So we've gone ahead and built an entity linker model. Like I said, this is a little outdated. This is a few years old, and I won't go into many details either. This is a whole separate talk. I'm happy to talk about this at some other time or offline. But basically what we did is we created a large sort of feed-forward network where we look at the mention in text. So take the sort of sentence embedding of the mention, let's say Hamilton, and then also an entity candidate. So the candidate in this case is the Wikipedia page. So we add the textual mention and the Wikipedia page, we throw it in a feed-forward network. And what sort of comes out is a probability whether or not in that particular context that is the right Wikipedia page to link to. And then we'll basically train on this because we have all of that gold standard data from our interwiki links that we harvested. So we trained this model. Cool. And we got 79% F-score. That's good, right? We were happy with that. 79% is a decent enough high number, we think. I guess it's pretty good, right? 79%? Not sure. So let me tell you how most clients and users think about performance, because I don't think a lot of people in the data science world think like this, but this is important to understand when you're communicating performance numbers to your business clients. What they usually think is, well, 100% clearly is the best model ever, and everything is entirely correct that the model predicts. And 50% is like the worst model, because 50% is like random guessing, right? No. A random baseline is almost never 50%. I mean, maybe if you're throwing some dice and looking whether it's an odd number or not, then it's 50%. But usually in real life world cases, this is not the case. In fact, for our entity linking task, if you go and look at the English Wikipedia, there's 7 million articles on it. So if you pick one at random, will have, this number on the slides, 0.0014%. Let's just call it 0%. If we just pick a random one, we'll have 0% accuracy. And at this point, it doesn't really matter whether it's F-score or precision or recall, it'll be 0%. And in fact, our upper bound wasn't 100% either. We had some efficiency requirements in this particular project, which meant that we couldn't keep all of the whole database of Wikipedia concepts, again, 7 million, so quite big. So we only kept 14% of it. Of course, we were, we tried to be pretty clever about it, and we tried to keep only the concepts that are often mentioned in sentences, concepts that are really relevant, because Wikipedia also has a lot of niche concepts and so on. So when we keep those 14% of all the Wikipedia concepts, then we calculated that, or let's say an Oracle disambiguation step that would always pick the right one, if it is there in that database, then that Oracle would obtain 84% F-score. So that at the time was a reasonable trade-off for us, keeping only 14%, still being able to disambiguate 84% of our cases in our data set. But it meant that we've significantly lowered the upper barrier, basically. So the modeling now targets a 0 to 84% range. Cool, that's interesting information because, in a range of 0 to 84%, 79% is really good, right? Michael on the slide is unsure, and I'm, I think by now you see me coming, that we're still a little bit unsure about this. Of course, I've done this on purpose. Why? Is because I want to say that you never really know what this 1% number means unless you put it into perspective. So how shall we do that? What we really need to do here is to develop some simple baselines so that we can better understand the complexity and the data challenges of your project. And I will run you through doing exactly that, just to give you sort of a feel on how that looks like and what that would feel like in your own project as well. So in our case, obviously, we won't be assigning the mention Hamilton in a sentence to any random page on Wikipedia. We're not that stupid, right? We're not just going to assign a random one out of the 7 million ones. We could do something clever. For instance, we can obtain a list of Hamilton candidates by doing either some very simple lexical search or doing some more complicated fuzzy search, whatever it is that you want to do. Depends a little bit, again, on the precision recall trade-off that you want to hit. But let's say that we just look at things that are called Hamilton. And for instance, there is a musical. There is a Duke of Hamilton who lived in the 17th century. Of course, there's our race driver. And then there's also an Alexander Hamilton, who was an American military officer in the 18th century. Never heard of him, but he's a valid Hamilton candidate. We might be talking about him in our sentence, who knows? If we do this for all of the instances in our data set, so all of the mentions that we have that we want to disambiguate, we create this, let's say, plausible list of candidates just by doing a lexical search. And then we pick a random one from this list. Then we actually obtain 54% in F-score. This is pretty clever because we've just been doing a very silly thing, just something very stupid. And I'm always a fan of doing stupid things first because it helps you understand what your data looks like. It helps you understand how far you can get even without doing any machine learning, any fancy stuff at all. So 54% in F-score we obtained. That's cool, but we can create an even stronger baseline, I'm sure. Let me introduce you to the concept of prior probabilities. So a prior probability is kind of a measure on how often a mention is linked to a certain concept. So for instance, if we have a sentence and we have no notion of the rest of the context, but we just see Hamilton, all of these cases on Wikipedia, let's say that 75% of them will eventually link to our race driver. It's just because this word or this person is being mentioned more often than other Hamiltons, like Hamilton the musical. I don't know whether anybody knows Hamilton the musical. I'd be happy to hear whether it's a good one. And then maybe 7% of all these Hamilton cases on Wikipedia point to the 18th military officer, 18th century military officer, and so on. Then again, if you have the actual string Lewis Hamilton on Wikipedia, you might imagine, of course, that these cases will much more likely be referring to our F1 race driver, so maybe something like 99%. And if it's Alexander Hamilton, of course, the prior probability that this is referring to the 18th century military officer is also pretty high. So I hope that this sort of gives you an intuition on what prior probability means. You can sort of compare it as well to when I say Obama without any other context. Most people will be thinking about the former US president, even if they haven't heard of any other of the context. But this is sort of the prior probability because that term most often refers to that president. What we can do with these prior probabilities is just sort of extrapolate them to the extreme and just say that whenever we see a Hamilton, whatever the context is, we'll just say that it's the F1 race driver, 100%, because the prior probability was 75%, 75% is majority. We'll just call it 100%, call it a prediction, and call it a day. And then for Lewis Hamilton, the same, and Alexander Hamilton will be the military officer. This is just a very black and white thinking, and this means that we don't have to look at any context at all. The funny thing is that this prior probability baseline actually obtains, in our case, on the data that we had at the time, 78.2% in F-score. And this is super interesting because, again, we haven't done any machine learning, we haven't tried to analyze the context at all, and it shows you something about how skewed our data is. It shows you that a lot of the entities are, so prevalent that they sort of swamp the data set. And if you just sort of, predict the most likely thing without thinking more than that, you will actually get 78.2%. So this is really good to know. And taking it back to the question that we had before, so our machine learning model on the one hand is supposed to disambiguate based on context. It obtained 79%. Our relatively simple, if not to say quite stupid, baseline obtains 78.2%. So is this a good model? Yeah, maybe not so. Or maybe the data is flawed. And so this is exactly the point that I want to make. By developing these baselines, you will get an idea on how difficult your challenge is and what the context is for interpreting your performance measures. So this is what I said. The baselines put your machine learning's performance measures in the right perspective. Let's go back because we're not done. Let's actually revisit that upper bound again. Is it really 100% if we have no memory or efficiency requirements? So let's say that we didn't have to prune that database and we did keep all of the 7 million concepts, would we still be obtaining 100% precision? Well, and this is a little bit sort of the philosophical part of the talk. What does correctness even mean? 100% precision means that every disambiguation is correct. But what is correct? And let's not stay philosophical too long. I think it's a Saturday night, it's late, so let's make it a little bit more concrete, I think. We have this favorite sentence of mine, which reads, Hamilton won the Belgian Grand Prix in Spa in 2024. Now let's look at the entity Spa. And we're still wanting to disambiguate this to the right Wikipedia page. So I present here for you two sort of candidates, two plausible Wikipedia pages. On the left, we see the circuit of Spa-Francorchamps. So this is the circuit, the racing circuit that lies in Spa. And it's often also just sort of informally referred to as Spa. And then, of course, there is Spa, which is the city of Wallonia, and which is where the race circuit clearly gets its name from. So let's try and do a little bit of live annotation here in the room. And let's say, suppose that you are the annotator or even the user of this system. You're reading this sentence and you want to get a link out on the word Spa to a Wikipedia page. Which of the two would you prefer? Would you want it to link out to the circuit or to the city? So let's do it by hands. Maybe the circuit. Who wants this to link to the circuit? Quite a few people. Who thinks or who would prefer this to link to the city of Wallonia? Also a few people, also quite a few people, but significantly less people. So I think in this case, there's really no wrong answer. If you think in sort of grammatical way of parsing the sentence, the Belgian Grand Prix is in Spa, in the city of Spa. That's where its location is. But you can also say sort of semantically, well, it was on the circuit of Spa that he won it, so maybe the left one. So I think both are sort of valid explanations. So I think, I've never had the chance to do this kind of thing in a large audience, so let's do a few more. I have two more. So let's go through this one. Societies in the ancient civilizations of Greece and Rome preferred small families. We have two options here. Again, on the left, we have an article that is talking about the ancient Greece, basically a Mediterranean civilization in the Greek Dark Ages, so sort of ancient Greece. And then on the right, there's the current country, Greece, as we all know it, which is a current country in Southeast Europe. So again, hands up for who thinks we should disambiguate this to ancient Greece. Okay, that seems quite a lot. And who thinks it should be current Greece, current country of Greece? Okay, I'm with you guys. I also think that this should be current country of Greece. Why? I think because I interpret this in a sort of, again, grammatical way. Ancient civilizations of Greece, of the current country Greece is how I read the sentence. But it's, as you see, it's quite sort of a personal preference. And on Wikipedia, you will always often find that they will go ahead and link the left one because it's sort of more informative. If you want to click through and read about the specific topic that you're reading in this sentence, it probably makes more sense to go ahead and read more about the ancient Greece, right? Cool. One more. Because this one, well, I had a bit of a discussion about this one, so I want to see what your opinion is. So full metro systems are in operation in Paris, Lyon, and Marseille. So on the left, we have the option of linking out to an article that is a specific article about the Marseille metro. There's a whole article about this on Wikipedia. And on the right, there's the actual article of the city of Marseille. So who wants to disambiguate it to the left one, the Marseille metro article? Not so many people. And who would want to link it to the Marseille city? More people. Okay, so this time it feels like you're going with the grammar, sort of grammatical explanation. The metro system is in Marseille. So Marseille is the city of Marseille. And maybe we want to know more about that city because we have 3 cities in this list and we want to know more about Marseille. It's a nice city to visit as well. So it's interesting to see, and this is what I wanted to do and see this sort of ambiguity in the room actually, because that's kind of my point. Often when you have multiple annotators labeling or curating the same data sample, they don't always agree. So this is where that sort of philosophical question comes in of what is correctness. And you can measure this by looking at inter-annotator agreements or IAA, which basically will tell you how often annotators agree if they label the same data sample. If you have high inter-annotator agreement, you're really good because it means that the annotators mostly agree, the goal data is reliable and robust, and that's really good. It's a good sign for your project. If the inter-annotator agreement is low and your annotators disagree, that might be because of various reasons. Maybe the data is confusing, dogs versus muffins. Maybe the label scheme is ambiguous. Maybe your annotators are just a bit confused about the label scheme, and we'll see a few examples of that later on as well. Or maybe the NLP task is too complex, and this is something that you definitely shouldn't rule out. So basically, whenever you run into this low IAA stuff, go ahead and look at your data and critically think about your challenge and your data and what it is that you're doing and why this is ambiguous. So let me show you an example of this. Let's go back to our portal. And let's assume that we have all of these newspapers coming in, but we really only want to show Formula One news, right? But we have all of these articles coming in and we need to decide whether or not they're related to Formula One. So this is kind of, this is taken from an actual project that I did with a client 2 years ago. I just changed the domain a little bit to match the Formula One team here. But so what the client did was give me an ontology, sort of a label scheme, as you can see on the left. And then we had all of their articles that we needed to label. And the requirement was that we should put exactly one label to each article in these newspapers, right? So we did that, we had some annotations, and then we plotted the inter-annotator agreement of the labels. Again, this is a little fabricated, but it looked more complicated even in the project. But let me walk you through the slide and show you what is on here. So basically, there's a bit of a color scheme going on, going from 0 in blue to 1 in yellow. And what you would expect is that if all of the annotators would constantly agree on every data sample, then you would just see ones on the diagonal. You would just see yellow ones on the diagonal and zeros everywhere else. But what we see here is that, for instance, between US politics and global politics, we don't see a 0, which means that there are some articles where maybe one annotator annotated it with US politics and the other annotated it with global politics. So what it really gives you is some confusion between these two labels. And I guess between global politics and US politics, that is something that we can all kind of understand. Maybe there was something happening. I couldn't really imagine what could be happening in the US that could have sort of a global effect. But let's say that there was something confusing going on there, and the annotators didn't quite know how to label it. Could happen. In these kind of cases, you can definitely consider merging labels if humans can't reliably distinguish them. I'm not saying that this is particularly the case for US politics and global politics, but there might be other labels where the distinction might not really be relevant in the end. So we've seen, I've been involved in projects where annotators just spend a lot of time trying to distinguish between labels that at the end at the end of the sort of downstream business case, it doesn't really matter which of the two labels was applied. And in our case, this is true as well. We're only caring about Formula One. I don't care about politics at this point. I think that's a good stance to be in at this point in time. So let me just watch Formula One and be happy here. Let's just call it politics and be done with it. But there's a few other cases in this sort of confusion matrix that are more interesting. So for instance, there was some overlap between US politics and Formula One. That's weird, right? You would certainly think that your annotators are clever enough to see the difference between Formula One and US politics. Whenever that happens, and these kind of cases happen often in projects, just go and look at the data. The data will tell you what is going on. And you will see something like this. There's an article here about how the founder of the Haas team, Gene Haas, funny guy, he owns the Haas F1 team, and he was basically saying that it's really difficult to decide where to invest and how to go, about making business decisions in the Formula One racing domain because of something that was happening in the US, something about international tariffs. I haven't followed. I was watching the Formula One races. I'm not sure what happened there. But you can imagine how one annotator says, well, this is clearly about Formula One, right? Formula One is impacted. It's even one of the founders of the teams is there. And then another annotator is saying, well, this is clearly US politics, right? So there was a lot of confusion. When we saw this data, I was basically able to say to the client, well, you see, this is why we should put more than one label on one article, right? That seems like an obvious thing to do, but the client was very adamant in the beginning of the project that we should label each article with exactly one label. And only when you have sort of start collecting the data, start collecting the ambiguity, and can show some cases to the client where that actually doesn't make sense or where you run into some sort of gray area, then you can convince them to maybe reframe their NLP task. And that is exactly what we often see happens. I think this is something that maybe in the beginning of your career, you don't realize as much, but often enough, if there's a client coming to you with a specific question, they have a specific task that they want you to do, you can often reframe it. You have to look at the data and understand what is like the best approach for this particular data and this particular challenge. So don't be afraid to do that. Then the last sort of case that I wanted to explain on this confusion matrix, it's not really a confusion matrix, but for lack of a better word, is something going on in the sports category. And to understand what the problem is here, we basically have to revise the ontology again. What happened here is that on the root category, we have a sports category that has subdivisions in football and Formula One, makes sense. Then we have politics, and then another root category is leisure. And within leisure, there's another subcategory called sports. And so some of the annotators just glanced over the ontology and put sports or the other sports, so basically 1 sport and 3B sports. And this was where some of that confusion happened. And you might be saying, well, Sophie, this is a little silly example, but this is, I promise you, it was worse than this on the actual data. There were names that were sort of duplicated all through the ontology, so that really needed to be cleaned up. And remember when I talked to you about this domain expert before, and I really still stand by that statement, it's very important to talk to the domain expert, have them explain why the ontology is like this, because they often have a good reason, but then still try and sort of guide them towards a revision of the label scheme that makes more sense, and that will introduce less ambiguity in your data overall. Okay, let me just take a quick sip. So that's all fine and well, and if you have multiple annotators, you're a very lucky girl or guy. But I can kind of hear many of you thinking, well, that's fine, but I don't have multiple annotators. Like, they are costly, that's human labor. Maybe we don't annotate all of that much data anyway. So what do I do? What do I do if I don't have these multiple annotators and I can't really create these confusion matrix and so on and so forth? Well, the other thing you can do is you can analyze discrepancies between your model's predictions and the gold standard label. So this is kind of sort of a little game between the model and your human annotator, if you have one human annotator, which in the worst case can be you. So this is what happened in the original entity linking project. We have here a certain Agnès Maria. I'd never heard of her before, but she was apparently a queen of France, and she died in 1201. And so the gold annotation on Wikipedia at the time when I was harvesting this data was that if we read the sentence, she was a queen of France, the gold annotation linked this to the current country, France, right? That makes sense in a way, but then on the right-hand side, you see the prediction of the model, where the model actually found this Wikipedia page that I didn't know existed about a certain kingdom of France in the Middle Ages. And if you go and read the details of this, the timing is exactly correct. So the 1201 time period fits into this article that the model predicted. And it's times like these where I get a little emotional and be like, well, model, that's really well done. You know, you've gone and looked at the whole of Wikipedia and found this very specific article about France in 1201. Nice. But at the same time, the gold annotation is the current country. So this is a incorrect prediction if we measure it as such, right? So, and this was also one of the problems behind that 79% performance number, is that there was a lot of sort of issues with the data set. And that is why I wanted to do this live annotation with you earlier, to show you what that kind of ambiguity really looks like and feels like. So here you can really question, is this an incorrect prediction? Or maybe the label is wrong. Maybe the original, writer on Wikipedia should have linked to this Kingdom of France article. Maybe they didn't know about this article, because it's very, very frequently you would just link France to the current country, France. That's a sort of understandably action to take. The other thing you could say is, well, maybe both answers can be correct, right? And this is something that I've come to sort of realize throughout my career. I think in the beginning, when I was doing machine learning and doing performance evaluations, I was very sort of black and white. Something is either a false positive or a true positive. It's either correct or incorrect. And I think I've stepped back from that a little bit, and I think that makes sense to do. So this is a chart that I showed, that I basically sent to a client only 2 months ago, where I was analyzing some data from them, and I was doing the evaluation. And I basically said to them, okay, so I've found a lot of cases that are correct with the model that we built. So these are the blue ones, the largest portion. And there's definitely some that are clearly incorrect, the orange ones. And then there's some cases where I'm saying, the prediction and the gold label are not the same, but they are related. It's kind of like this France versus the old France, or Greece versus the ancient Greece, or Lyon versus its metro system. They are related. And it will really depend on the downstream usage of your data and of this application, whether or not you will be happy with those related cases. And if it really matters whether which of the two, in the end, we end up resolving to, then we should go and have a look at this data, maybe make some better annotation guidelines and so on, make sure that this data is more firm. So in the end, I basically just communicated the precision is between 87 and 96%. I think that's okay. The other thing that you should do, I think this is a really cool trick to do, if you have a supervised model, if anybody still does that, I think there's still plenty of use cases where you can use small supervised models, is basically apply them to their own training data set, and see which ones they predicted wrongly. Because what you will find are structural data errors, and I want to show you an example of this. It's really a neat trick, and I don't think a lot of people are doing it. So let's say that we have a manually annotated training data set where we're annotating the names of circuits, so basically Grand Prix circuits. So in the first sentence, to kick off 2025, Dutch Grand Prix weekend in Zandvoort. Zandvoort is the racing circuit in the Netherlands. So here, Dutch Grand Prix is the entity that we're extracting, that we're labeling as being the circuit name. In the second sentence, we have Gasly Lemons, a quite sad Monaco Grand Prix crash last week, unfortunately. So here, Monaco is the name of the circuit and is being annotated as such. Of course, there's many, many more examples like this. Then when we train a supervised model on this kind of data and apply it back on its same training data, and this works especially well with small models, because they are supposed to generalize, they cannot memorize every single entity in the data set. They will try and sort of define internally generic rules that will help them make predictions. So in this case, the model predicted that Monaco GP is the entity instead of just Monaco, as we saw in the training data set. And you can easily find these discrepancies just by comparing. And so what happens here, we saw several of these cases, so we dug into this data more. And what we noticed is that the words Grand Prix were sort of half of the time annotated as part of the entity, and the other half of the time was outside of the boundary of the entity. So as you can see in the first two examples, Grand Prix is annotated as part of the entity, and in the second example, it isn't. And then the model got confused, rightly so. Again, this is where I sympathize with the model, and I'm like, yeah, you're right. This was just confusing to you, and you've done your best. So this is actually not a bad prediction, but it tells you should go back and probably re-annotate your data. And when doing so, it really helps to write up annotation guidelines. So if you're ever lucky enough to work with like an annotation team, or at least one person, a domain expert who wants to annotate your data for you, make it very easy for them to be consistent in their predictions. They will do this annotation over several days, maybe several weeks, and they will have to make decisions that are sometimes in a gray area. So it really helps to give them specific examples, to be as clear as possible in specific instructions. For instance, in this case, we can decide that Grand Prix should be inside the entity annotation. You can also, decide the other way around, whichever you want. But it's also nice to have these annotation guidelines because it will also help you to do some semi-automated checks on your data set once you've been able to define all of this. Finally, correctness, as we discussed it before, may also depend on the downstream usage of your results, and we've already hinted towards that a little bit. So when we go back to this example that we saw where Hamilton was winning in Spa, and Spa is either the circuit or the city in Wallonia, it doesn't really matter if we're not looking to link out to a Wikipedia page, but for instance, we just want to know Hamilton and the Belgian Grand Prix, and we just want to, extract the correct Grand Prix happening. So this was July 2024. If that is our end goal, then it probably doesn't really matter so much what the intermediate step is. We will probably arrive at the correct answer in the end anyway. And this is kind of what I mean by defining the right hill to climb. You have to understand what it is that in the end is necessary in the downstream application that your client is using, how they will be using this data and these results. And so by defining that right hill to climb on, you can set yourself a sort of correct evaluation framework that you can then start working towards. So defining the right hill to climb is really thinking about, is your data correct? Is it consistent? Is it robust? Is the test data representative of the real world data? Very important and something that is often overlooked, especially by clients. And does your evaluation framework really capture the value of your algorithm in production? Have you talked to the domain experts? Have you talked to the people who will be integrating this data and these results into their downstream frameworks? And do you really understand how those results will make a difference? And does your evaluation capture that value? Only after you've been able to define that right hill to climb, then you can get to the fun stuff. And those are 5 more presentations, unfortunately not for today. Then we can get into the algorithm development, do the model training, the LLM fine-tuning, and so on and so forth. So let's wrap things up with a practical checklist, because I'm sure after 3 days of PyCon, you're all very enthusiastic to go back to your computer and start implementing projects. And if you're working on machine learning or natural language processing projects, I just want you to have sort of a checklist in your head that you can use to make sure that you're making the most out of your work. So first and foremost, when you're looking into a machine learning project and you're doing data annotation, make sure that your label scheme is consistent and unambiguous. And I would even say, even if you're not doing data annotation, because most projects will have a label scheme. Even if you're working with LLMs, whatever you're doing, you will have some sort of schema that your data will need to be put into. Make sure it's consistent and unambiguous. If you are doing data annotation, draft clear annotation guidelines. It takes a bit of work, but it will pay back in ensuring that the data is consistent. If you have multiple annotators, measure this inter-annotator agreement, IAA. And if it is low, you have to go back. You have to go back and either reframe your task, reframe your guidelines, think about your data critically and understand why the IAA is low. Talk to your annotators, understand why things are ambiguous and why they have made certain decisions. Do this sort of exercise that we did here in the room and talk to the different people and try and understand why somebody was linking it to the ancient Greece and why somebody to the current Greece. And I think another important point is to model that uncertainty in your annotation workflow. When annotators are annotating, don't just give them black and white examples. Also give them the option to say, I don't know, or this example is unclear, or maybe the data was parsed wrongly, because otherwise, if you force them into a decision, they will click something and they will make a decision, but your data will just simply be, it will not be good. When you're doing performance evaluation, think about that 79% that we had and where we were unclear whether this is actually good or not, and develop simple baselines to put performance into perspective. Like I said, I'm always a huge fan of doing the simple thing first. Just try and do something stupid in the beginning. Maybe doesn't even include machine learning or an LLM. Just have some statistics, do some statistics on your data and see what you can come up with. Remember that prior baseline that we had that already had 78%. It told us a lot about our data. You can quantify realistic upper and lower performance bounds. It's not always 0%, it's not necessarily 50%, and it doesn't have to be 100% at the upper bound either. And then measure performance as part of the larger business process. And this really takes you to go and talk to the client and understand what it is, why they're using this data, and how this will be impactful. Then a few sort of tricks that I like to use is identifying structural data errors by predicting the training data. This is specifically important if you're creating supervised models. And then, of course, that's just a little trick, running it on the training data. That's not how you should measure performance, clearly, but have some truly unseen data where you measure the realistic performance of your model on actual unseen data. And then finally, make sure that you're climbing the right hill. So I know that this was a lot, and I probably talked a bit too fast, so I might have won us some time to get back to the conference. But if there's only one thing that you remember out of this talk, it's that Hamilton won the Belgium 24th Grand Prix, not Russell. Thank you.
Okay, so that was lovely, Sofie. Thank you so much. So we'll take on the questions now. So first question for you is, how important is time as a dimension in your inferences? Do weightings depend in any way on recency? And would that have helped with Hamilton and Spa?
Yes, exactly. So that's a good question, and clearly it is very important. So when I was showing you the articles about first Russell winning it, I think this was at 4 p.m. and the same day at 6 p.m. It was Hamilton winning it. So clearly, if you look at that timestamp, you will be able to make that distinction. But then months later comes this episode of Drive to Survive where they repeat the storyline that actually it was Russell who won it. So in this particular case, you might create some, or let's say Netflix has created some confusion by sort of distorting the timeline again. So it's not a magic bullet, is what I want to say. It's you definitely need to take that into account when doing the filtering, when doing the disambiguation, but not a magic bullet, unfortunately.
Okay, so next question is, was it surprising to you that 80% of data science is cleansing?
That 80% of data science is cleansing? Yeah. Surprising when I came out of uni, yes, maybe. I don't think anybody has ever told us when I was at uni. I happen to kind of like that part of data science, so I like digging into the data. It's actually surprising to me how often data that you think, well, this will be fine, right? Like the client will give me that and I will be able to work with that. There's always a day of work of cleaning it. So one example that I had that didn't make it into the slides, but that is quite related, is when a client was giving me news articles, so very similar to what I was showing you here. And they said, well, it's a clean database of news articles. And so they give me these news articles where I don't know exactly how it goes, but there's clearly some broadcasting process going on. So I don't know, Reuters or something broadcasts an article, and then other journals take the same article, they change it ever so slightly, and then publish it again. So what you end up having is all of these artificial duplicates from all of these newspapers, that all of the sentences are almost the same. And then if you go and create a supervised model on that, it might be that half of these very same articles could be in your training and the other half in test. And if you hadn't noticed that, you'd actually creating a huge bias because of that. So yeah, looking into the data, cleaning it, it's always step one, and you need to continuously do it. But I happen to like it. So yeah.
So next question is, Do you kind of cross-check your model against commercial LLMs? How do they fare?
So it depends, right? So the models that I'm creating often have features or sort of, well, generic LLMs just are LLMs. They just output text. The projects that I typically work on are with sort of structured information. So this is classifying things, extracting information, and they don't typically come out of the box. You have a lot of models on Hugging Face. Sometimes there are models that are sort of doing similar things on Hugging Face that you can then try and compare with. But often enough, there are sort of custom tasks that need to be done. They're not like chatbots. Because I don't really work on generative AI, more of the extractive.
Okay, so more on the next question. Do you use libraries like CleanLab to automatically check label quality? If yes, what's your opinion on them?
It depends on the project. I don't know the specific library that has been named here, but I do apply several libraries. It depends on the project, what kind of data looks like, what the labels are, and then try and plot sort of characteristics of the data. So for me, this is part of, let's say, the first week of the project, where you just look through the data and throw some libraries at it. There's indeed several good libraries that find outliers, that find maybe mistakes in the data set. So there's definitely a whole suite of libraries to use there. That would be a separate talk.
Okay, so next question for you is, what is the take on the impact of LLM on NLP? So how would it change the way past projects were implemented?
So I didn't catch the impact of LLMs on?
So I will repeat the question. So what is your take on the impact of LLM on NLP? How would it change the way past projects were implemented?
I mean, clearly it's blown the whole field of NLP out of the water, right? So LLMs, I think, have been huge, clearly. So yeah, I've been doing NLP for almost 20 years, and the way that we're doing NLP now is just completely different than the way that we did it with before. That said, I do think that there's still cases where we can use, like I said, smaller supervised models. I don't think we need to throw an LLM at everything. I love experimenting with LLMs, but I also like sort of doing that trade-off and seeing if I use a lot less memory and a lot less GPU power with a small model, and how will that sort of compare to an LLM. Maybe an LLM gets 5% better in accuracy, but maybe that trade-off is something that the client is happy to sacrifice if they want like a real-time framework or something like that. So to me, it's another tool in the box, but it clearly has overtaken most of the NLP field. But I don't think that we should forget everything else. I still think that we have like a whole arsenal of tools to use.
Okay, so next question for you is, bias is a metric with a specific meaning in statistics and ML, and it is normally never zero in practical cases. It is used in a different way in common context. How do you teach your client/user about the difference? Could you repeat it again? Okay. Sorry. Bias is a metric with a specific meaning in statistics and ML, and it is normally never zero in practical cases.
Right.
It is used in a different way in common context.
Right.
How do you teach your client/user about the difference?
Yeah, that's a good question. In general, this kind of concept, I would never try and explain the statistics behind it to most clients. Not because I think most clients are dumb, by far not. But what I think they are most interested in is the impact that bias has on their use case. So if there's bias in the data, and this is preventing us from creating a good model, for instance, then I would try and explain it this way, and I would try and sort of explain the impact that it has on the larger project. So it's more of sort of a domain-specific, use case-specific approach to it that I think makes more sense, and that more clients will be more interested in than sort of the theoretical framework of it, if that makes sense.
So I think we are done with, would anyone like to ask any questions? I'll pass on the mic. Is anybody interested? No?
The QR code should also link out to LinkedIn, so always happy to connect or talk offline as well, if there's any questions.
Okay, so thank you so much. A big round of applause for Sofie, please.